Hello everyone, welcome to Advances in Mahr Air Gaging. I'm your presenter, George Schuetz, Director of Precision Gauges at Mahr in Providence, Rhode Island. And if you have any questions during the presentation, use the chat feature in the GoToMeeting function, and I will respond to your question after the webinar by email. Again, thank you for attending. We have some objectives for today. We're going to understand why air gauging is a valuable dimensional measurement solution. We'll provide a little bit of understanding of air gauging theory, learn some of the applications for air gauging. Then we'll learn some new processes for improved deliveries that Mahr Incorporated is using now. We'll talk about some new display options. And we'll also talk about air gauging and setting masters that wrap up the whole air gauging system. So air gauging really isn't anything new. It's been around since the 1940s, but in the 1940s it was really the first truly high performance tool for the shop floor. Now you can imagine back then that there wasn't too much in the way of electronics or optics or any other high performance measuring system. So air was the first way to get 50 millionths or 1 micron or better measurements at the point of manufacture. And it's really even more important today. Tolerances are getting tighter, and we can also use air gauging to look at some of those form factors out there. So here's a little chart that shows since the 40s how much tolerances have tightened up. And air gauging is still a great way of measuring those tight tolerances today. So we refer to air gauging as a fixed variable gauging system. It's a comparative measuring system that gives us variable data. Because of this, it is the most accurate way to make dimensional measurements. You can get the actual deviations if you're interested in collecting data or doing process improvements. Because the air tool is made to the specific dimension that's being measured, it has the least operator influence. When you're collecting data, you can learn about the form, the process trends, and diagnose manufacturing issues. It's the fastest and easiest to use because the operator simply has to place the air tooling into the part that's being measured. While it has limited measuring range, it's very good for that one specific size. And initially, it can be a pretty large investment, but with care, it can last decades when the system is maintained. And because Mahr builds the accuracy into the air tooling system, it's a single master system which requires only one setting master for its initial zeroing. So again, variable gauges are made to a specific size. So why air gauging? Well, air gauging is that comparative measurement system that allows for fast measurement because it's self-aligning. The tool is made specifically for the dimension that's being checked. You can get very high resolutions of 5 microinches or 0.1 micron. It's really the easiest to use, and because, again, it's made to the specific dimension, there's virtually no operator influence on the measurement. Air gauging is non-contact, which means that the actual measurement isn't made by contacts, but of course, the body of the plug is apt to touch the dimension that's being measured, but the sensing part is non-contact. And because that sensing is air and the back pressure in the air, it tends to clear away any liquid surface contamination. So it's great to be used at the point of manufacture. When else do we use air gauging? Well, when our tolerances are pretty tight, tighter than plus or minus a thousandth and a half or 40 microns. It can be used over a wide range of different sizes, starting from 3 millimeters or dimensions of 1,000 millimeters or larger. Air tooling can be made to any of those specific sizes. It's good to know when, because it provides the variable data, it allows us to know not only if the part is good or bad, but how good or bad that part is for our data collection purposes. And because it's fast and easy, it's really good if you have a high volume of parts to measure. It measures those parts quickly with minimum operator influence. But if you have a low volume, very tight tolerance, and you want to measure it out at the point of manufacture, a custom air gauge may be the only way of doing that. And air gauging is good for geometric measurements. So if you want to measure tapers or straightness or explore for diameter variation, air gauging is a great way of doing that. And if the environment is dirty, again, air tends to clean away some of the liquid contamination. Is air gauging difficult to apply? Well, no, it's really no different than any type of gauging tool that you have out there, whether it be a snap gauge, an adjustable bore gauge, a plug gauge, for example. You still need to know the same information. What's the size we're trying to measure? What's the size tolerance? Where is that measurement going to be made? And in the case of air, it's also good to know what the surface finish is. And because, like I mentioned, air tooling is custom made for the application, it's really important to ensure that we know what the size and the tolerances are, because the tooling is made to those specifications. And if you don't get that right, well, that tool can go and become a nice paperweight, or it can go into the scrap heap. So it's very important to understand the application when specifying air tooling. Well, let's just briefly talk about the principles of air gauging. Well, just like you take a garden hose and hold it against the wall, the distance between the nozzle and the side of the building, as that gets smaller, it starts to restrict the water flow and pressure builds up in the hose. As you change those things, you're going to get different characteristics. The closer the hose, the higher the back pressure. The same thing with flow. The closer, or just the opposite, the closer the distance, you're going to have less flow. So things are related, and you can create a pressure distance curve with water, but you can also do the same thing with air, because water and air act very similar. So if you took an air jet, for example, and you put a restriction in front of it like we have here, and then plotted a curve of distance versus the pressure that's going on there, you would get a pressure distance curve. And you can see on this example that there's a very linear portion of that pressure distance curve. And that's basically what we're going to be using to measure the dimensions with our air tooling, the use of this linear area from this pressure distance curve. So when you control the air pressure coming into the system, and you can control the manufacturing and the position of the air jet, or the orifice the air is coming out of, and you can control the manufacture of the air plug, and you calibrate them all into a known pneumatic zero, you can create a very repeatable air gauging system. And you can use that to display dimensional measurements. So Mahr manufactures this precision into the air tooling, but we also do the same thing to the readout system and the master or the reference standard that we manufacture and is being used with the air tooling. So what this does is it makes all these items interchangeable with each other, and you can still have a known performance with the system. So Mahr manufactures the precision into its air tooling. Now, what's an air gauge system consist of? Well, it consists of three major factors: the readout, the master, and of course, the air tooling and its accessories. Now, the air tool is, well, it's probably the most critical component in the air gauging system. It establishes the reference the part dimension is compared to. Now, an air tool consists of, well, lots of subtle components. Basically, it's nothing more than a hardened steel cylinder in the case of an air plug, where air passes through and comes out of a pair of opposed jets. So as you close off the jets or throttle that airflow coming out there, the pressure will build up, or the back pressure will build up, and we can use that to create our pressure distance curve. So our air gauging system, or any air gauging systems, measures that back pressure and displays a part size. And again, if you can control all those, you can have a very reliable, repeatable, and interchangeable air gauging system. So you can see here we have the air plug, we have the air jets, and we have some escape channels here, which the excess air can be relieved and flow out of the hole, for example. Now you can do a lot of things with that concept, with that back pressure concept. You can create a tool that measures length, just like an LVT, and measure a thickness, for example. You can create air plugs, either in a through hole or a blind hole configuration. You can turn that air plug inside out and measure ODs with an air ring. Or if you want to measure ODs on the machine, you can create an air snap gauge to go on there and measure the OD while the part's still in the machine. Or you can even combine those two things, combine an air plug and an air ring to get a match gauge, or measure the clearance between two mating parts. It's also important sometimes to measure part geometry at the point of manufacture. Now, sometimes, roundness or some other features, to do it right, you need a true roundness measuring system, or a CMM, or something else to measure the form per a standard. But sometimes you can create an air tool to tell you the characteristics of that form. So now you can get a good indication with an air tool of the taper of the part, or the squareness, or what the straightness is. You can also use it to measure center distance of the diameters. So you can get some geometric measurements out of a piece of air tooling. Now, air plugs for diameter are by far the most common tool that is manufactured. It's an easy measurement of diameter, but if you take that air tool and move it around in the bore, you can explore for some form conditions. For example, you can go straight up and down, and you can measure diameter, size at a few locations. If you rotate the air plug, you can check it for orvality, 2-point lobing conditions, or even lobing conditions. If you explore the bore axially, you can look for barrel, taper, and hourglass shape. So you can get some form indication from the air tool. Now, before I mentioned that surface finish is something that's critical for air tooling. Now, air tooling uses, like I said, an air jet or an orifice for creating the flow, and the restriction creates the back pressure. And that orifice is about 50 thousandths in diameter, which really is measuring over a surface area. And as you know, all surfaces have some surface finish or roughness conditions to them, tool marks, etc., during the manufacturing process. So the air gauge has to fill in those peaks and valleys to create the back pressure. If that surface roughness is very high and those peaks and valleys are very deep, well, you look at an averaging condition where the back pressure is built up at an average location of those peaks and valleys. And when that surface finish is rough, you can get a difference between a contact measuring system, which rides only on the peaks, and an air gauge system, which is working on back pressure. So that's why we'll always ask, what is the surface finish of the diameter when we're going to apply air gauging to make that measurement. So if you're measuring tight tolerances, it's important to know and understand the surface finish of the part. Like I said, air plugs are the most common tool used, and they come in different styles. We saw a little bit of this before. We have through holes for through hole bores, blind holes when we need to get into the bottom of the bore. We can have longer body lengths where you can have a continuous diameter, or they could have a measuring diameter and then be brought down to a clearance diameter. You can put stop collars on your air plug to set the jets at a specific depth or to match up with a small land on the bore. And you can also get air plugs that have either a 2-jet, which is the most common for IDs and ODs. Sometimes we need to use a 3-jet air plug. If we know that part has a odd lobing condition, well, a 3-jet air plug is the right way of measuring those lobes because you won't see them with a 2-jet application. And you can also add multiple jets where you can get 4 jets to give a average of 2 diameters 90 degrees to each other, or even a 6-jet plug is going to give you an average of the 2 and 3 lobe roundness conditions. So you can get lots of things, lots of different information based on how you make that measurement by the number of air jets you have. So keep in mind these pictures with the air jets, and we're going to come back to that in a minute. You can also do, like I said, air rings or air snaps for measuring ODs. Again, air rings can come in 2 or 3-jet applications. You can put the jets at various locations from the face, again, if you need to hit at a specific part or a specific land on the part. And you can make air rings become a bench, or they can be handheld in a portable device. Air snaps, of course, are used at the point of manufacture. They can be single or multiple circuit configurations, and used for a wide range of OD applications. Again, we can put very similar things to stop collars on them to make sure they align to a location on the outside diameter, or we could put multiple circuits into an air snap to get a taper or those types of checks on the OD. Now I asked you to look at and remember the jet. Well, that's a great feature about air gauging. The air jets or the sensors they're very small, and thus they can be positioned very close together. There's probably no other sensor that can do this at the same cost or at the same capabilities of an air plug, for example. So you can get sensors that are typically 100,000ths of an inch apart, or maybe even closer. So this provides the capability of doing multiple dimensions or geometric checks in a single tool. So you take a look at this tool here. We're measuring 3 levels of 2 different diameters. Now try to think of that if you had to do that with contact gauging or some other means. You would have levers, and if you could even do that, it would be very difficult. But with the air tooling, this is pretty basic manufacturing and able to get these multiple diameters all in one fixture. And you can get some pretty small diameters. You know, some of the hip implants and so forth are very small tapers. And again, with the air jets, they're very small. You can get multiple circuits into a very small diameter. So the jet is a great feature about air gauging, the size of the jet. So like I said, we looked at that small taper there, and that's what we're doing with taper gauging. We're measuring two diameters at a known distance, and if you know that, you can calculate the angle of that taper. So tapers are used in a lot of different places. They're great for locking things together and ensure that they're held straight and strong, and that's often in machine tool tapers, or in the medical implants. You'll see tapers used quite often because they can be a locking taper with a known distance as the taper matches up. So we talked about the air tooling a bit. Let's talk about the next part of the air gauging system, the readout. Now, customers have specific preferences for display readouts, and Mahr has a wide range of options. Whether it be bench mounted or computer aided or portable, Mahr has a readout for the application. Now, Mahr's most basic Dimensionair has been around for a long time, but it's great for customers who like to have that analog display that give us a sense of size. It's very fast response. You can get small or large dials. It's easy to adjust with its single zero setting. And you can see that because the tool can attach to the front of the unit, it can act as its own stand if you want to have a bench-mounted air gauging system. Still a very popular product. We also have a very portable product, low-cost product in our Micro Dimensionair. It's a truly portable handheld display, basically wrapped around our Micro Maxim digital indicator with selectable resolution, provides actual value and tolerances. It's really our lowest cost display option for air gauging. It's great for use in the machine inspection, and the handle arrangements can be done in a number of different configurations to offer the most comfortable and easy to use for the operator. And you can also bench mount it for a nice bench mounted, low cost, portable bench mounted system. And then we go into our electronic bench mounted displays. We have our 832 digital Dimensionair, a single or dual input, so we can measure tapers on this as we wanted to. It has a nice large digital display. It's really a full feature bench amplifier with actual values, tolerances, normal reverse polarity, data output, etc. And the same features can also be found in our 1840 column. This has a large 3-color LCD display and the digital readouts. They can be built into automated systems because they have machine control capabilities, and they're stackable for easy use and side-by-side readout. So if you're doing multiple dimensions, you can take a quick glance and see if both dimensions are all within tolerance or not. Again, this is a full feature column display, and basically the preference is in the operator. Do they like to see the column format, or are they more interested in the digital resolution? We have some new display options with our C1700 PC with our cockpit software, which is a simple and easy to use user-definable software program using our modular components for customizing the gauge solution to the application. So this is a powerful multi-input and cost-effective gauging solution. But we have some more powerful custom gauging applications, which have the gauging, the PLC, the statistics, etc., all in one solution, being part of a manual, semi-automatic, or fully automatic solution. So powerful capabilities for multiple part and automatic air tooling selections. And the last part of the air gauging system is the master. Since the air gauging system is a comparative measuring system, a known reference standard is required. And as you know, Mahr knows precision. Mahr manufactures, measures, and certifies its own masters. So we have the equipment not only to manufacture to millions, but we also can measure our results. All measurements are traceable to the standards of the United States. Our Grandmaster primary standards used at our measurement center have all been directly certified by NIST. And as you can imagine, with millions measurement, the environment is by far the biggest contributor to measurement errors. At Mahr, we've created an ideal environment, a metrology laboratory that's ranked as one of the finest in the world. We have very tight temperature control, a complex air filtration system that cleans the air and reduces temperature stratification. And all of this is built along a large, independently supported 375-ton concrete slab that reduces vibration from the environment. And of course, the Mahr Precision Measurement Center is certified. We have our NABLab certification, ISO 9000, certified by NQA. So we have the necessary documentation to back up our measurements. And of course, we use our own equipment for master certification, whether it be our precision length measuring machines, our IDO and OD comparators, our ULMs. We have the tools to measure to sub-microns. So therefore, we can probably provide the highest quality commercial certification of masters in the industry. Mahr Labs provides the lowest uncertainties. We know the metrology, and you can go to our website and look at our uncertainties to compare them with anyone that's out there. Now let's take a look at some advances. You know, we've been manufacturing air gauging for a long time now, since the 40s, but it's always good to reinvent the system to make the products better. So we had some recent product announcements, which we're going to talk about here. Some small improvements, some big improvements, and some faster improvements. We had product announcements about new air hoses we're using. We've developed some new standard and configured air plugs with new processes and new coatings. And of course, the cockpit air solution is a new application for many of our air gauging systems. Now, small changes is air hoses. We standardized on a new configuration that replaces most of our older low mag air hoses. You know, typically we had air hoses for 1, 2, 3, 5, 10, 15, 20, 30 feet in the past. So what we've done is gone to a different system that basically is configurable by the user. And this air hose comes packaged in a 6-foot length with a little instruction manual on it that is interchangeable with all the displays and tooling that we're using now. It has the same male and female thread. It has the swivel connector on them. But today, the hose is removable from the connector via snap fitting. So if the customer needs to change the length of the hose, all you need is a tool to cut the length, and now you can create the air hose to the specific application that you need. So one order number now for all our air hose kits, and the user can configure the tooling to the application. We're stocking and shipping this air system hose now. Another thing that we've done is we've developed a breakthrough process for the manufacturing of air tooling. And we had a goal for this. We wanted to lower our costs and improve deliveries and make us really a leader in the delivery of air tooling. So we've invested in a new multi-spindle axis machine and developed a breakthrough in intelligent part programming to produce a standard and configured air plugs all in one machining operation. The result is a faster, less costly plug and the capability of doing more under standard configurations. Now this manufacturing process is very fast. I'm just going to show you a portion of it. And what the operator really has to do to create an air plug is go into the part program and enter 4 parameters into the machine. Once those 4 parameters are entered into the machine, the machine is going to simulate the part being manufactured, and the operator puts the touches off the tooling that's in the machine to the slug that's in there, and within this 24-minute processing time, an air plug is going to be produced. So 4 parameters, start the machine, and now the air plug is ready to go on to the next process. So that's greatly reduced the time of in-shop handling for us for the plug, and it also alleviates other machines or relieves other machines to do more special type air tooling applications. So because of this process, we're going to be offering better and quoting better deliveries on standard and configured air tooling. So Mahr is now going to schedule standard air plugs and their uncertified masters for a 2-week delivery after the receipt of the customer order. If a certification of the master is required, we will process with a 3-week delivery. And this is going to apply to all our standard DP50, DP20, basically all our low magnification air plugs entered through this standard configuration process. And if there are multiple plugs on an order, we'll offer 2-week delivery on up to 10 sets of masters and air plugs on the same order. And we expect to have similar improvements when we have larger orders. So moving standard air plugs to this new machining and manufacturing process, again, is going to free up other resources, resulting in a general decrease in all air gauging lead times. Another advancement that we're working through now is some new materials. You know, Mahr is beginning to reduce chroming with the goal of eliminating the whole chroming process. And as you can imagine, chroming is expensive, it's hazardous to the environment and to people, it could be difficult to control, and it's subject to flaking and chipping when the part is hit. What we're doing now is we're going to be going to an aluminum chromium nitride-based vapor deposited system for all our special air plugs that we used to do chroming before. So this type of aluminum chromium nitride coating is something that's used on cutting tools, hobs, and bits. It's very high resistance. You can see that it does come with a darker color, so it will stand out from a standard air plug. It's extremely hard. It's beyond the normal hardness reference systems. It has very good shock resistance. It offers good rust resistance, so chroming is not needed for rust prevention. And really, it may be too good because it can make air plugs last far longer than they have in the past, even the chromed air plug. So this is a new process. It's standard. It's part of our configured air plugs now, and I think you'll see a great improvement in the wear characteristics of air plugs. And also new this year, started in the end of last year, is our C1700 PC. Again, this is our modular-based air system where you can have a standard USB module, interchangeable modules for LVDTs, air tooling, input-out control, all run by our cockpit gauging software. It's easy to use, has lots of good features, and it's something that customers can configure to their specific application. And it's also great for multiple circuit air tooling for taper applications, multiple diameters, or if you have multiple stations of single diameter tooling. Let's take a couple of looks at different applications here. Here's a front suspension arm measuring taper at the ends, and basically this is a taper gauge with two modules. We had different sets of tooling for each taper. We used a quick disconnect air hoses. It was pre-programmed for each part, and it provided the operator with two diameters and the taper angle. Similar application for a medical taper now. Again, two air modules, two sets of different tooling, the quick hose connector, program for each part. And again, we're measuring two diameters and the taper angle. And with this specific application, we could not measure at the gauging line that the customer wanted with the air tooling. So we're, again, with the cockpit software, able to project where that or what the diameter is at the location the customer wanted. All done very easily and easy for the operator to use with our cockpit software. And finally here, a rear extension housing. This was a case of using the cockpit software with 3 air plugs and an air ring. So again, we've used a standard USB module, our P2E modules, programmed it in a guided sequence operation where the customer goes through a routine using the 3 air plugs and the ring, and then getting the total results at the end of the measuring process, and that data can be sent off to be collected for SPC applications. Again, all done with our N1700 PC and the cockpit system. So you see a lot of improvements. We know a lot about air gauging, but why Mahr for your air gauging needs? Well, like I said, we've been around doing air gauging since the 40s. We have the experience with air gauging. We have the application know-how. We saw that Mahr builds the accuracy into the tooling, but also the displays and the masters. So we make the whole thing. We make the tooling, the gauging, the masters, and the display, all manufactured here at Mahr. So we've covered a lot today. We've learned that air gauging has been around since the 1940s, and Mahr has been around since that time. It's a very highly accurate, minimum operator influence measuring system. Air gauging is ideal for many ID and OD type measurements, and it's built specifically for the application, making it fast and easy to use. Mahr is working to maintain its air gauging leadership role by investing in new processes, such as our breakthrough part programming, with the whole idea of lowering the cost, selling prices, and providing faster deliveries. We have these new high-tech coatings that are environmentally friendly but produce a better product. And I think Mahr has the best application support. We're here, we're open, we're taking phone calls, and you can reach us any day for your air gauging needs. And we also talked a little bit about some of the new products, our new hoses and accessories, the new tooling, the better deliveries, the better coatings, the cockpit and modules, and our with more capabilities and added flexibility for your air gauging needs. So I think all of these are making Mahr an air gauging leader in the technology and value for you. So with that, I'd like to thank you for your attention. If you had any questions, make sure you put them into your chat box. Thank you for attending the webinar, and have a great weekend.